All right, guys, who's out there? Who's out there? Who's out there? Waiting on questions. The most people I've had right at the beginning of a login. What's up, Spencer? You have questions? You get your work done? Well, we go from 5 to 3 to 2. Wow, that was really fast. I ran a bunch of people off. Questions, concerns, comments? The entire week 3 packet for geometry or algebra 2? Wife disorganized this whole thing? Geometry. All right, let me find it. My wife was in here and I don't know what she did. So in week 3, I'm having you guys do a test for a parallelogram. A test for a parallelogram. And there's certain properties for a parallelogram. If you've forgotten those properties, I go back and watch the video on what a parallelogram is, because you're going to need those properties. On top of that, on your sheet, wow, that got really dark really fast. Huh, I need to fix that. But on your sheet, that's not going to work. Give me a second. But on your sheet, give me a second. What is that? Weird. Hasn't done that before. On your sheet, you have 5 parallelogram tests up top, right? So within those 5 within these, we're going to work all these different examples of how to prove or show something's a parallelogram. So day 1 is actually working on the midpoint and the slope. So the day 1 is only working on the first 2 tests. Yeah, it's just the first 3 tests. In fact, it says we're doing tests 1, 2, and 3. So I'm going to walk through each one of those tests. So the first test, it basically says the opposite sides are going to be congruent. That it says both pairs of opposite sides are congruent. Well, that seems easy enough, but the way we're going to do this, instead of using the distance formula to show boom, 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 and boom, showing them over and over again, we're going to set it up as an algebra problem. So I'm just going to walk through 1A. So on 1A, we have this possible parallelogram. Kept getting a decimal point. Well, let's see what I get. All right. So we have this possible parallelogram of A, B, C, and D. And we have 2x minus 5. We have 3x minus 18. 2y plus 12. And 5y. All right. To find the value of x and y to make this this a parallelogram, all we're going to do is, because we know opposite sides have to be congruent. Congruent means an equal sign. So I can say 2x minus 5 equals 3x minus 18. And we'll solve this one. Now we also know that these opposite sides have to be congruent, so we could say that 5y equals 2y plus 12. All right, from here it's just algebra. I'm going to subtract 3x from both sides, and I have a negative x minus 5 equals a negative 18. I'm going to add 5 to both sides, and this gives me a negative x equals a negative 13. And because both these are negative, I can divide by a negative 1. And that gives me x equals 13. So when x is 13, we know these 2 sides are congruent. All right, over here, subtract 2y from both sides. I've got 3y equals 12. Divide by 3 on both sides, and I've got y equals 4. So if x is 13 and y is 4, this is a parallelogram, because that would make these 2 opposite sides congruent, and these 2 opposite sides are congruent. I think you did your algebra wrong if you were getting a decimal. So this is how you do 1A, 1A, and 1B. 1B's got the angles here, but it's the same idea. Opposite angles are congruent. So you would just set your opposite angles equal to each other and solve just the same way. Just watch your algebra. And then the other one is I will do 2A to see if it's a parallelogram. Let me erase real quick. All right, so let's do 2A. I got a decimal on 2A though. Okay, that's okay. So on 2A, you may get a decimal because it's a slope. But let me show you what you're looking for. Just because you get a decimal doesn't mean you're wrong. You have to know what you're looking for, what that number actually represents. So on 2A, we have these points. A is -6, -3. We have B, which is 2, -3. We have C, which is 4, 4. And then we have D, which is -4, 4. So the first thing I'm going to do is I'm going to do a rough graph. Well, that's like really bright. Let me turn the brightness down. That's a little better. So much better. All right, so I'm going to do a rough graph of this before we break so I make sure I'm getting everything set up correctly. So here's a rough graph. So here's my origin. So I've got -6, -3. This is A. I've got 2, -3. Well, these are on the same line. This is B. I have 4, 4. So if this is 2, 4's got to be here, and then 4's got to be up in here somewhere. So that's C. And then I have -4. Well, if this is -6, it's got to come on inside a little bit, and this is D. So it passes the eye test. So it kind of looks like a parallelogram, but without the math behind it to show it, we can't guarantee that this is a parallelogram yet. So what we need to do on this is we need to find the slope of opposite sides, because if the slopes of the opposite sides of a parallelogram, the slopes are the same because they're parallel. So we need to find the slope of AD, of segment AD. So we find the slope of this line, and that should equal the slope of BC. So if these two slopes of these two lines right here are the same, we know that these two sides are parallel. We're going to do the same thing with the other sides, that I need the slope of AB, and it has to equal the slope of DC. Okay, so that's the whole idea. So do a rough sketch, figure out which ones of these are the opposite sides, and go from there. Now we just need to use my slope formula, which is, let's see, my slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Hey guys, I'm the only one here today, so as y'all are putting stuff in the chat, I'm not going to look at it until I finish this problem, okay? So 2b and 2c didn't look correct. Okay, so if it doesn't look right, still do this part, but more than likely it's going to yield that it's not a parallelogram. So if you understand how to do 2a, this is the concept. Trust yourself. If you get these the same, then they're good. I know Mr. Shotwell today was saying, he's like, some of your points are so far off. I'm like, it is what it is. So either it is a parallelogram or not a parallelogram. So if you do 2a, 2b, 2c, all the exact same way, and if these are true, right? If they're not true, then it's not a parallelogram. So you only have one of two options. Either it's a parallelogram or not a parallelogram. If the slopes of the opposite sides are equal, then it's a parallelogram. If the slopes of the opposite sides are not equal, then it's not a parallelogram. So if you know how to do 2a, then you know how to do 2b and 2c. And don't trust your eyes. This just gives you an idea so you know which sides should be opposite. So I'm not going to finish working this if you know how to do 2a, because then you know how to do the rest of them. You good with that, MD? And then, Tori, I'll get to your question in a second, okay? All right, cool. All right. So I'm going to jump over and answer Tori's question, and I'll come back to look at day 2. Okay, MD? All right, so Tori, week 3, day 3, question 2. When I factor everything out, I should only get x minus 2 left on the left side. Also, where's the dog? The dog's probably asleep. Probably asleep. And I didn't even set up my Kodacam, so my wife's not here. He follows her around everywhere. So that takes care of the important question, where is the dog? Let's see. All right, so week 3, day 3, question 2. I think it's this one. Week 3. Yeah, this is week 3. Day 3. Question 2. When I factor everything, I should only do x minus 2 on the left side. Let's look. So x plus 1 over x squared plus 4x plus 4 minus 6 over x squared minus 4. Okay, so let's factor. So we have x plus 1 over x plus 2, x plus 2 minus 6 over x plus 2, x minus 2. Okay, so you gotta be careful on this. I see you have x plus 2 on there, but if you notice there's 2 of them here, you need to have 2 of them over here. So you actually need to multiply this one by another x plus 2, because it should have 2 x plus 2's in the bottom, and then this side with the x minus 2 over the x minus 2. So be careful, just because this has an x plus 2, this also has an x plus 2, but it actually has 2 of them. So that means this one also has to have 2 of them, Tori. And I think from there you can finish it out, right? I can finish it out if you want me to, but I think you'd be good. Hey, so MD, while I'm waiting for her to answer, see if she needs me to finish this out. Day 2 of the geometry packet is the same idea, except it's different tests. What is that supposed to mean? OJ? I don't get it. We're week 3, day 2, number 1 and 2, and day 3, all of it. Okay, cool. I can work with that, MD. Tori, what do you mean by OJ? Or is that supposed to be okay? Because I think J's next to K. Was that a typo? I think Tori had a typo. All right, cool. All right. So, MD, let's look. So, let's see. Week 3, day 2, 1 and 2. Oh, so the whole thing. Okay. So, I'm going to work 3 of these problems. Wait. Nah, I'm going to work 2 of these problems and kind of tell you how to set up number 2. Because that's actually pretty straightforward. So I'm going to work 1A and 1B. I'm going to walk you through it because these are 2 different tests that you can show that something's a parallelogram. So the first thing is on 1A. So 1A. We have A is -6, -3. We have B as 2, -3. We have C as 4, 4. And then we have D as -4, 4. Okay. Now, once again, rough sketch. -6, -3, 2, -3, 4, 4, -4, 4, right here. So this is A, 2, 3, this is B, C, and D. Now this actually asks you to find the midpoint. And properties of a parallelogram is if we have our diagonals here, this line and these segments bisect each other. That means that this segment and this segment are going to be congruent. If you look at number 2, that's what's actually happened on number 2 with the algebra, is these are congruent, so you would just set these equal to each other and solve for x. Set those equal to each other and solve for x. So that's how you solve number 2. But we know that these should also be congruent. Well, if these bisect each other, they should have the exact same midpoint. So this one actually asks you to use the midpoint formula to show or figure out if this is a parallelogram. Well, I actually need to find the midpoint of segment AC because that's a diagonal. So if you remember my midpoint formula, I suck at math and didn't do the first packet, so I need help with all of that. Okay, Spencer, that's cool. Have you watched the videos? Because the videos will help tremendously on that first packet. And nobody cares, I'll get to day 3, number 1 here in a second, okay? All right, so let's do the midpoint here. My midpoint formula was x sub 2 plus x sub 1 divided by 2, y sub 2 plus y sub 1 divided by 2. Okay, so that's how I find my midpoint. So I'm gonna find the midpoint of AC. So I've got -6, so -6 plus 4 divided by 2, and then -3 plus 4 divided by 2. Well, this gives me, let's see, 2 divided by 2 is going to give me a 1. This gives me 1/2. Okay, so my midpoint is at 1 1/2 for AC. If DB has the exact same midpoint, it's a parallelogram, done. So let's do this. 2 plus -4 over 2. And then -3 plus 4 divided by 2. All right, so we should get the same. Oh, this is a negative. This gives me a negative. -6 minus 4 is -2. Divided by 2 is -1. All right, so let's see. 2 minus 4 is -2. -2 divided by 2 is -1. 4 minus 3 is 1. Gives me 1/2. Because these two have the exact same midpoint. Because AC and DB have the same midpoint right here that we calculated, that means that this is a parallelogram. So that's how you would do 1A. All right. Yeah, Spencer, really watch those videos. Those videos will help you tremendously. And then you'd be able to answer questions because I actually geared the entire lesson off of either you look at the week 1 was a little different, but week 2 I really started gearing the entire, and really everything's geared off of the lessons from those videos, where those videos will walk you through how to solve those type of problems. Because I know you guys kind of struggle with math, everybody in general. So I try to mimic a classroom as much as possible, how I work examples in class. All right. Nobody cares. Hang tight for one more second for one more problem, and I will show you your problem, okay? All right. Let's see, 1B. 1B actually asked me to use the slope and distance, and I have an A at 5, 6. I have B at 9, 0. I have C at 8, -5. And I have D at 3, -2. All right. Now we need to find the slope and distance of exactly one opposite side, because that's what the test actually tells me. So I want to, once again, sketch this out. 5, 6. If this is 5, 9, 0. If this is 9, 8, -5 down here somewhere. And then 3, so if this is 5, it's got to be over here. -2 somewhere up in here. And then this is going to be D. All right. So there's my shape. Doesn't really look like a parallelogram, but can't be sure. What we want to do is we want to check exactly one opposite pair and see if it is parallel and congruent. To do the parallel part, we're going to do the slope formula like day 1. So let's see if we can find slope of DC, and that should equal the slope of AB. Right off the bat, if the slopes don't match, you can stop, because at that point it's not a parallelogram. But if it does match, then we're going to move on to the distance formula. So let's look. The slope of DC. So we're going to do -2 minus a -5 over, wow, just 3 minus 8. This gives me -2 plus 5 gives me 3 over -5, so a -3/5. So this is DC. And now we're going to do AB. So AB would be 0 minus 6 over 9 minus 5. This gives me 6 over 4, which gives me, if I even reduce that, is 3 over 2. Well, 3/5 and 3/2 are not the same thing. Done. Not a parallelogram. That's all you have to do. Check the slope and then check the distance formula. If they both these numbers match on both of them, it's a parallelogram, and that's how you work it. All right, nobody cares. Week 3, day 1, number 3. My dog bumped my camera, so I'm gonna have to readjust it. I have less room to write because I moved it forward. Boy, this blue is hard to get off. Okay. You got 2/3. I get 3/2. If it's not the same, if the slopes are the same, then you can just simply do the distance formula, and then the distance formula, if you get the exact same number, then it's a parallelogram. That's all that's really happening there. All right, let me jump on to Algebra 2. Algebra 2, day 1, number 3 from Algebra 2. Day 1, number 3 from Algebra 2. So you're talking about the x plus 2 over x cubed minus 27 times x squared plus 3x plus 9. You're talking about that problem, nobody cares? Perfect. All right, so rational functions, factor everything. This is a special factor. It's a difference of cubes. You have to go back and look at your notes and see what the special factor is, but my difference of cubes is a cubed minus b cubed is going to equal a minus b, a squared plus ab plus b squared. So you have to remember that special factor to be able to factor this. When I factor it, watch what happens. I get x plus 2 over, after that, can you do number 2 on day 2 and for some stuff on page 3? Yeah, sure. Yeah, I'll do that MD for you. So after this, this factors to x minus 2, and there's going to be x squared plus 2x, wait, 3x, what am I doing? That's not a 2, that's a 3. 3x plus 9 times, and I want to write this as over 1, x squared plus 3x plus 9 over 1. All right, so from here, we can, now that we're fully factored, we can look to simplify, go top to bottom. Does anything match? No. Top to bottom, anything match? No. But we can also look at the diagonals. X plus 2 and 1, nothing matches. But if you look on this diagonal, this x squared plus 3x plus 9 matches. It's on the top and on this bottom diagonal. They simplify out. And when I simplify this, I get x plus 2 over x minus 3 times 1, which is just x plus 2 over x minus 3. That's your answer. Now we want to know the domain. The domain is we're going to look at the bottom on my denominator and set each of these not equal to 0. So I can get x minus 3 does not equal 0, and x squared plus 3x plus 9 does not equal 0. Well, this is easy enough. This is x does not equal 3 by adding 3 to both sides. Here, you have to use, it doesn't factor, so you'd have to use the quadratic formula. But I'm going to do the discriminant because I'm only caring about real answers. If this is going to give me an imaginary complex answer, I don't really care. So when I do the discriminant, if it's negative, that means I get 2 complex answers and I can stop. I don't have to finish the math. So the discriminant is what's underneath the square root. which is b squared minus 4ac. Well, my b is 3, so 3 squared is 9, minus 4 times my a is 1, times my c, which is 9, which gives me 9 minus 36, which is going to give me a negative 25, which means that this is going to have two complex answers. So the only real number that x cannot be would not be 3. So my domain is going to be the set of all x's, such that x is an element of the real numbers, and that's why we're going to not use these answers, the complex ones, because it's a real number, and x cannot equal 3. Done. Easy peasy. The factoring, this right here, that difference in sum of cubes is what really gets you guys. It always gets you guys, so I'm always going to have it on problems. All right, so I'm going to do number 2 for you, MD, and then we're going to look at page 3, because page 3 gets into rectangles. All right, so number 2. Let's go back to geometry, number 2 on day 2. So here's the deal. I give you something that looks like a parallelogram. And then I give you diagonals. And I tell you this diagonal right here, that diagonal is 2x plus 3. And I tell you that this diagonal is 5x. I then tell you that this is 8y minus 36, and that this is 4y. And I say find the values of x and y that make this a parallelogram. Well, for that to be true, for this to be a parallelogram, to find the x and the y, this length and this length, they have to be the same. They have to be congruent. So that leads to an equation of 8y minus 36 equals 4y. Same thing on this diagonal. This segment should be congruent to this segment. So we just set those equal. We have 2x plus 3 equals 5x. This is a lot like those problems on the previous page. From here, we're just going to solve. I'm going to subtract 8y from both sides. This gives me negative 36 equals negative 4y. Divide by negative 4. I get y equals 9. That's easy enough. Right here, I'm going to subtract 2x from both sides. And I get 3 equals 3x. Divide by 3. X equals 1. So the key to this is knowing that this segment and this segment is congruent. Congruent leads to the equal sign. And then this segment and this segment are congruent, which leads to these equal signs to solve out the algebraic equation. Fairly straightforward, I think, personally. All right, so let's look at page 3, MD. Anybody got Algebra 2 questions? Anybody got Algebra 2 questions before I jump into day 3? All right, so on day 3, I don't know why I grabbed a pen. Can't use a pen on this. On day 3, we get away from just a generic parallelogram. We actually start looking at special parallelograms. We're going to be looking at special parallelograms: a rectangle, a square, and a rhombus. Square and rhombus are coming next week. But the rectangle is the first special parallelogram we're going to have. So right up top, I give you the properties of a parallelogram. I wonder if it's because it's on autofocus. That really bothers me. All right, nobody cares. I'll get to that in a second. It's really bothering me that this is getting darker. My camera on autofocus? Yes, that's why. Now let's see. Still does it. I don't know. All right, so we're going to have to use these properties to show that something is a rectangle. So Do you want me to work 1A or B, or do you want me to work number 2? Because really, it's going to be properties. I'll tell you what, I'll do 1A. I want to go answer an Algebra 2 question, then I'll come back and do 2A, okay? Is that good, MD? So nobody cares after I do this 1A, I'm going to go ahead and work your problem, all right? All right, so we have, 1A, we have D is 9, -1, F, which is 9, 5, G, which is -6, 5, and then we have H, which is -6, 1. All right, so we want to know if this is a rectangle. Well, the first thing we need to do is figure out, is it a parallelogram? Well, okay, that's fine, day one. That's great. Nobody cares. I'll get it. We need to figure out if it's a parallelogram, because a rectangle must be a rectangle is a parallelogram. So in this case, I'm going to use the slope test, and I'm going to explain why. So I have 5 tests I can choose to pick to see if this is going to be a parallelogram, but I'm going to use one very specific one, and there's a reason why. So first thing I want to do is I'm going to trace it out. So I've got 9, -1. I have 9, 5. I have -6, 5, and -6, -6, 1. Did I type that right? Yep, -6, 1. So right off the bat, if this is D, F, G, and H, if I want to show that this is a rectangle, it already doesn't pass the eye test, but I need to show it mathematically. My best bet is going to be to do these 2 sides right here to show it's not mathematically, because for it to be a parallelogram, the slopes have to be the same. So if I don't have the slope of GF, segment GF equals the slope of HD, then it's not a parallelogram, and I can stop. It can't be a rectangle if it's not a parallelogram. So we're just going to throw this in here. So let's do GH. Let's see, 1 minus 5. 1 minus 5 divided by -6 minus a -6. Did I really do that? Yes, I did. It's okay. I'm going to show you why. I do GH? Oh, I did GH, that's why. I'll do GF. Buggers. So GF. 5 minus 5. 5 minus 5. -6 minus 9. This gives me 5 over -15, which gives me a -1/3. All right, so this is GF. This is the slope of GF. So if the slope of HD is not -1/3, we can stop. It's not a rectangle. If it was a rectangle, they'd be parallel. And I'll tell you what we'd be looking for if they are, and I'll refer back to the example on the page. So that's GF. So let's do HD. So HD. So let's do 1 minus -1. 1 minus -1. I can already tell you it doesn't look right. -6 minus 9. -6 minus 9. This is going to give me a 2 over a -15. Last time I checked, -1/3 is not -2 over 15. You mean 5 minus 5? Yes. Which that becomes a 0, and that becomes 0. Still 0. And then here on HD, let's make sure I got 1 minus a -1. So 0 does not equal -2/15. It's not a rectangle. Now, if you look at the example, the one I give you is an actual example, and the reason why I did this, and I'm gonna erase this and give you the scenario. So I'm going to give you the scenario of why we do the slope to see if it's a rectangle. So if I have a slope of 1/3 and a slope of 1/3, let's just say these are opposite sides, and then the other opposite sides is -3 and -3. if these were the slopes of opposite sides of a parallelogram, I know it's a rectangle. The reason why is a rectangle has 4 90-degree angles. That means that these two intersecting sides have to be perpendicular. Well, what we know about the slope of a perpendicular is it's a negative reciprocal. So if I take 1/3 and I flip it upside down, I would get 3 over 1, which is just 3. And if I change the sign, I get -3. So if you have a slope of -3 and a slope of 1/3, they're going to form a 90-degree angle. And if all these sides are like set up like this, you're going to have 4 90-degree angles. That means you have a parallelogram with 4 90-degree angles, and you can say at least it is a rectangle. That's why we do the slope test, to look for this type of scenario to see if the lines are perpendicular, see if those segments are perpendicular. All right, so nobody cares. Day 1, week 3, day 1, number 6. And then I'll jump over to 2A, okay? MD. All right. Number 6. Good. X squared minus 6x minus 27 over 2x squared minus 2x divided by x squared minus 14x plus 45 all over x squared. All right. Rule, very first thing you do with any rational function, factor. My top is going to factor to x minus 9, x plus 3. That gives me my -27 and my -6. I have a GCF here of 2x. That gives me x minus 1. Still divided by my top here, that's 9 and 5. So that's going to be x minus 9, x minus 5. And then the bottom is already factored. All right, now we're fully factored. I don't expect you to be able to do it as fast as me, but you should be able to factor fairly quickly. Nobody cares. All right, so from here, what I'm going to start doing is I'm going to start building a list of numbers that I can't put in here for x. Basically, anything that would make my denominator 0. So x cannot equal, if I look, well, 2x, if x was 0, 0 times 2 is 0, and 0 times any number is 0, so it cannot be 0. X minus 1, if I put 1 here, because all I'm doing is setting them equal to 0 and solving. If I put a 1 here, that's 1 minus 1 is 0, and 2 times any number, or 0 times any number is still 0. So it cannot be 1. And then right here is 0, so 0 is already there, so I'm good. So I know at any time right now, I cannot put a 0 or 1 in here because I'll get a 0 in the denominator. All right, let's look to simplify. Top to bottom, top to bottom, top to bottom, nothing matches, so we're good. All right, now from here, we have to remember our rule from dividing fractions. We are going to change my division to multiplication. We're going to take the reciprocal of the second fraction. The first one's going to stay the same. So x minus 9, x plus 3 over 2x, x minus 1. So the first fraction stays the same. Change division to times and take the reciprocal or flip the second fraction, which I now have x squared over x minus 9, x minus 5. All right, now let's look to simplify my diagonals now that I got multiplication. So I have a 2x and x minus 1 and an x squared. Well, this x squared means x times x. So I actually have an x on both that actually cancel out. I have an x minus 9 and an x minus 9 on my diagonals here, and those cancel out. So this simplifies down to x plus 3 over 2 times x minus 1 times x over x minus 5. Now let's look for excluded terms. When we flip this upside down, all of a sudden here, my x cannot equal. I still have my 0 and my 1, but now it can't equal a 9, and it cannot equal a 5, because at any time if I put those in, I'm going to get 0 in the denominator. So that's going to be my restriction for my domain. From here to multiply, we just multiply straight across, and we're going to get x times x plus 3 over 2 times x minus 1, x minus 5. And then from there, you can FOIL it out, and that's perfectly fine. The domain of this is the set of all x's such that x is an element of the real numbers, and x cannot equal conveniently the numbers you found, 0, 1, 9, and 5. Easy peasy. Just finished multiplying that out with distribution property. Pretty easy problem for me. All right, MD. Let's do 2A. All right, 2A for geometry, day 3. All right, so I tell you it's a quadrilateral. I mean, we tell you it's a rectangle. Okay, and we have diagonals going through here, and then we've got J, K, M, N, and Q. And then A says NQ equals 2x plus 3, and QM is 5x minus 9. Then it asks you for JQ. That's my question. So it wants to know this length right here. This is what it's looking for right here. It tells me that NQ is 2x minus 3. So this part right here is 2x minus 3. Then it tells me MQ, this part right here, is 5x minus 9. Well, in the properties, it tells us that the diagonals, all these diagonals are congruent and they have the same midpoint. So this length, this length, this length, and this length, they're all the same length. They're all the same length. So if I can find what x is and I know this length, well, if they're all the same length, then I know JQ. Easy enough. Well, if they're all the same length, which is congruent, congruent leads to equal. So I can actually say 2x minus 3 equals 5x minus 9 and solve from there. I can subtract 2x from both sides. I got negative 3 equals a negative 3x minus 9. Add 9 to both sides. I got 6 equals, it's not a negative 3x, that's just 3x. 3x divided by 3, we get x equals 2. Now, that's what x equals, you're not done. I actually asked you for the length of JQ. Well, if I know that NQ is going to be 2 times my x, which is 2, minus 3, this gives me 4 minus 3, this gives me 1. If this length right here is 1, that means all of these lengths are 1, therefore JQ is 1 unit long. Done. So the whole key to this is these properties on top. These properties on top. That's it. You have to look at these properties to figure out which one am I going to use to be able to solve these problems on the bottom. That's it. What other questions, guys? Well, that was a fast 44 minutes. What other questions? What other questions? Questions, anybody? Page 1, number 2. Which one, A, B, or C? Oh, I think I forgot to do that, huh? No, MD, I thought we talked about that. Because you said you knew how to do 2A, and that B and C were is the exact same thing. You're just finding the slope, and if all the slopes are the same, then they're going to be parallel, even if it's a decimal. You want me to do B? Let's do B. All right. So I have A as 5, 6. I have B, which is 9, 0. I have C, which is 8, negative 5. And then I have D, which is 3, -2. Okay, so we're going to do slope. We're going to look to see if the slopes are the same for the opposite sides, if it's a parallelogram. So sketch it out first. So I've got 5, 6, let's see, 9, 0, 8, -5, and 3, -2. Kind of looks right, but this will at least give me my launching points. So this is A, B, C, and D. So let's do AD. So I know that my slope of AD has to be the same or congruent as the slope of BC. So let's do that. So slope of AD. So AD, -2 minus 6 over 3 minus 5. This gives me -8 over -2, which gives me -4. Is that right? It gives me -2, -4. So let's find slope of BC. If these are not the same slope, we already know it's not a parallelogram. All right, so slope of BC. So we're doing -5 minus 0 over, let's see, 8 minus 9. 8 minus 9. Well, this gives me a -5 over -1, which gives me 5. Last time I checked, -4 and 5 are not the same slope, so this can't be a parallelogram. Did I do everything right? Let's see. AD. So -2 minus 6 and 3 minus 5 gives me -8 over -2, which gives me a +4. Not negative, so there's a mistake. +4. And then -5 minus 0 and 8 minus 9. This gives me a negative, yeah. So yeah, it can't be a parallelogram. I think it's really hard to see this, MD. These problems are hard to see with just the points here. Trace it out, because if not, you're going to have to find the slope of all 4 of these. And we could find the slope of all 4 of them, and 2 have to match and 2 have to match. But if you trace it out, you can stop after this if you know what sides are opposite, because if you don't have opposite sides or parallel, there's no point in doing extra math if you don't have to. What else? Oh, that one's slow. Thanks. What? Still schoolboy G. Jesse G. Yo H. Are you asking me, can you still message me on Schoology? Of course you can, if that's what you're asking. Oh, yeah. If you're not my student and you have a way to message me on Schoology, just send me a question. I don't really care. I mean, I'm a math teacher, and the whole team, at least me, Mr. Fitzgerald, Mr. Shotwell, worked on these questions and these packets together. So we're all on the same page. We're doing the same thing. So yeah, you can definitely ask. I don't care. Anything else? Anything else? Now, depending on your teacher, like my kids, if they stopped at 2 and they could tell me that it's not a parallelogram because the opposite sides aren't parallel, I wouldn't penalize them. You would want to message your teacher to see if they want to see all 4 of them, because we are a little different on that aspect. But yeah, I would ask Ms. Hawkins if she wants to see all 4 with the slopes versus the 2s. But I've worked with Ms. Hawkins enough where I'm pretty sure, and I don't want to speak for her, but I'm pretty sure she would be okay that if you showed 2 and you gave a written explanation on why it's not a parallelogram, she's generally been pretty good with that over the years. Oh, what other questions? Well, now all of a sudden it feels really slow since I've been working problems straight for 50 minutes. Oh, boy. Tired. Y'all been doing chores at your house, or you just been getting on your parents' nerves? I'm gonna go ahead and say no on that one. I took one chemistry class in college and made an A in it, but that was many, many years ago. I mean, it depends on what it is. If you're talking about balancing equations and stuff like that, I'm pretty good at that because I understand I can do the math behind it. But just general chemistry, not all that great. Do you have Mr. Cummings? Are you an AP chemistry or just regular chemistry? So Spencer, I do this. I start at 5 o'clock and I kind of go until I have questions, till the questions are finished up answered. But this is tutorials, it's not the actual lesson. So that's why I would need you to watch the videos to kind of see what's going on so you can actually try to work through the problems and see what questions you would have specifically for me. But as of right now, it's generally only been about an hour. There hadn't been a lot of questions, but I have a sneaky feeling the more kids, well, I have a sneaky feeling though the more because this is going to drag out for another 4 or 5 weeks, guaranteed, and the rest of that's still kind of a question mark. That there'll be more and more people on here asking me questions. So guys, I know you guys are here asking questions, but you need to tell your friends because if y'all have questions, they have questions too. They can come on here so I don't have to answer the same question every day, which I don't mind, but I know there's more than four people on right. There's 4 people on right now. I know there's more than 4 kids that have questions in math. So I have Hawkins, I have mine, I have Posey. Wonder who else. I had a Fitz student yesterday. Can your parents pick up our notebooks from the school? That's a great question. You talk about a notebook that you left in class before spring break that you guys leave there all the time with your notes in it? Because if that's what you're thinking, I would have to ask administration, and you would have to request it specifically through administration, so the teacher would have to tell the administrator exactly where it's at to get it. That's a great question. I don't know. An architecture class. I'll tell you what. I'll shoot an email over to Mr. Shannon in CMD. But if you message me on Schoology one-on-one, when I get an answer, I will respond back to you because that is a great question. Because I know a lot of you guys. In fact, I have students in my class that leave their notebooks in my class. They have all their notes in for the entire year. So if I'm saying reference your notes, well, they're sitting in my classroom. Can't do anything with that. So I'll shoot Mr. Shannon an email, and then hopefully he gets back with me within a couple of at least 24 hours, and then just message me individually, and I'll let you know. Okay. What else? What else? What else? I think my phone went off. Guys, I'll be right back. My phone went off. I gotta go see because my wife's not here. Ugh. Yeah, that's what I thought. It was my wife. Guys, if y'all don't have any other math questions, I am going to shut this down, and then I'll be back up at 5 o'clock tomorrow if you run into more questions. But MD, yeah, message me. I will shoot an email over to Mr. Shannon to see what he says, okay? Y'all got questions? Don't know. Don't know. All we know is right now we are out until the 3rd of, let's see, what is this, April? So, yeah, till May 3rd. So, as of right now, we'd be going back to school on Star Wars Day, May the 4th. I don't know. Not my decision, not my call. We'll let administration and our elected officials decide that for us. But until then, you got work. I'm here to help you. You're good. All right, guys, I'm going to go ahead and shut down the stream. So I will be back up at 5 o'clock. If you have more questions, or if you have friends that have questions, they can get on here too. It's pretty painless. So 5 o'clock tomorrow, guys. I'll see you then.